Hi guys, like the video. I'll be giving a virtual or mirror on CodeChef. Okay? Like the video, guys. By then, whoever is present. Can you guys see me well? Hello. Can you guys see me well? Can you guys hear me well? How long is the contest? 4 hour contest, right? It's a 4 hour contest. So should I set the timer myself? Should I set the timer from 6 to 10? So how should I set the timer? What do you mean finish it in one? I'm not that speed. Like I have to improve my speed, but I'm never quick. So yeah, I will start right now. Then I'll start with problems. Okay. So guys, I'll just start then. IICPC, right? So I will try to judge. Maybe I'll try to give you my tips that I give in general. My PC is somehow being slow. I don't know why. Yeah. So let me try to give the problems. Okay. A matrix problem. How do we pronounce that? Matrix or matrix? Matrix. There was an array A of size n with positive integers. You calculate a matrix B such that Bij equals to Ai plus Ij. Unfortunately, you have forgotten the array A, but you still have the matrix B with you. Can you figure out the original array A? So we have to figure out that. So let's go for something symmetrical, like sum of everything, or sum of diagonal, or let's say sum of diagonal. What does sum of diagonal has? Sum of diagonal has so let's go for something that is symmetrical that you can get out of it easily. Okay. If you see sum of diagonal is bii equals to ai plus ai, right, which is equals to 2 times of ai, right? So sum of diagonal will give you 2 of total, 2 times of total, and sum of row will give you ai plus aj, right? J equals to 1 to n, which is nothing but uh, sum of this, which is nothing but ai times n plus total, right? So we will get total by that, and then we will subtract total, and then we divide by n, and then we will have ai, and then we'll have our array a. So the problem is done here. Okay, what do we do? First we'll take the array input, and then what do? We'll get the total first. Total by equals to 2, because we have seen that sum of diagonal elements is twice of that, right? And once we get the total, we can output each thing easily now. Okay, let's get the row sum. And then what is ai? AI equals to row minus total by n, right? And then the problem is done. Let's submit this shit and see if it is passing. So yeah, problem one is quite simple. You are given something, you have to come back. You are given a matrix transformation. I tried going for whatever the symmetrical thing is. Okay, whatever the, we can even find sum of all elements. I think sum of all elements is also symmetrical. Total sum is also symmetrical. Sum of b equals to what is sum of b? You have AI how many times? You have AI here n times, right? And then here n times, which is nothing but likely n plus 1, 2n plus 1 times total. I think sum of total is this, I guess, because 2n minus 1. If you look at one AI, it is coming here and here. So that also would work to get the total. But this was simpler too. So let's go for the other problem. Oops! You just half the diagonal elements and return them. Easy peasy. I thought it will be a bit more difficult. I thought it will be a bit more difficult. Yeah. I should have done that. But then I thought it cannot be that easy. See, how I have operated was I didn't focus on what I want. I focused on what to get something. Instead of focusing on what I want is AI, right? Then AI is right here. I didn't focus on what I want. I just focused on to get something, to gain something out of it. So and then I went for total. Like, okay, I can get total. So I should have focused on what I want more because yeah, we have to focus on what we want more, right? Okay, let's go for the next problem anyway. This is very similar to the product positive problem. The only difference is you delete subarrays with product minus 1 instead of 1. What is product positive problem? Is it right here? Yeah, it is right here. Unless and Bob are playing a game on an array of size, and it is guaranteed that AI equals to 1 or AI equals to minus 1. Either AI equals to 1 or AI equals to minus 1. In single move, the current player does the following: choose L and R. If the number of minus 1s is odd, then you remove that. Ones doesn't play a role here. For the product to be minus 1, you want number of minus 1 to be minus 1, okay? If number of minus 1s in that range is odd, you can remove the whole subarray from the array, concatenate the remaining things in the same order. The player who cannot make a move loses. Alliance goes first and turns alternate. Predict the winner of the game. Further, as a proof of concept, if Alliance wins the game, you have to provide a valid winning choice of L and R for the first move of Alliance. So likely by the first move itself, it's decided who will win and who will lose. Okay. So let's try to say what are the most basic things we can say. You know what? I can also use this one now. Uh, let's try to say what are the most basic things we can say. Okay, don't see my handwriting. I can draw well. I mean I can draw well in general, but I haven't gotten used to this drawing pad to draw. So if total minus ones are odd, okay, if total number of minus ones are odd, Alice can remove everything and then Bob cannot make a move. That's an obvious thing. You can write it down, right? Let me write that down too. If total, so we have that example right here, is odd, Alice wins. Else total is even and Alice cannot, if Alice makes a move, She removes some odd, and that makes the remaining as odd. If the remaining is odd, Bob removes everything. So that's simple. Alice will lose here, and Alice loses. So it's simple. It's like if totally is odd, Alice will win. Otherwise, if Alice can't make a move, Alice lost already. If Alice can make a move, the other thing, the remaining will be definitely odd because totally is even, odd plus odd will be even. And then Bob can remove everything. So it's either Alice 1 comma n or Bob based on number of minus ones, right? I haven't overcomplicated this problem at least. In count of minus 1 equals to 0, if this is odd, it is Alice, it is 1. I cannot write it right here. It's Alice, it is 1, it is n, it is this, else it is Bob. Alice can even remove minus 1, and so on, but yeah, because every time Alice removes something, the game is very much forced. Bob will remove an odd minus ones, and then it will become odd again. And then Alice can remove even one thing, and then it will become again odd. So Alice can humiliate Bob a bit here. But we are choosing not to humiliate, we are choosing this. Provide a valid winning choice of L comma R. I think any minus one also will work. So let's try that. Because this is also a valid one, because L comma L is also valid. Because why? After this, Bob has even, and whatever Bob do, Alice can do further. So this also should pass. Why the fuck did it fail? This is a valid winning choice, right? Of first move, people will alternate. Their checkers are bad. Are their checkers bad? Wait, are their checkers bad, guys? Say now. Say, somebody say, like, are you guys not following the stream? L comma L, removing some minus one is also a winning choice, right? Because Bob is left with even. Whatever Bob does, Alice can remove everything again. So they have to be careful with their checkers. Otherwise, oh, my bad. Their checkers will be right because their checkers will be right. It's not difficult to figure this out. Sorry, my bad. It's correct answer. Yeah, their checkers are right because this is not a difficult problem. Like it's obvious. So now we are here. Expected product 2 for an array A of length and define f of A as product of a1 plus a2 times a2 plus a3 up to so on n minus 1. Given integers n and m, find the sum of f of A over all m power n arrays satisfying length equals to n, and values between m. So it's like a combinatorics problem, I guess, right? Like you have to count something, or count or summation, or like in a way they are same things. In a way, not exactly, but okay, maybe you have to compute something over all possible subarrays. Maybe I'm overcomplicating it. Maybe we'll do it like one after the other. Expected product. So why are they calling that expected product is because you're summing it over all possible things, right? So if the array is entirely random with values in between, that might be the expected product divided by m power n, of course, but they're not asking us to divide. They're asking us to sum it. So how do we sum it? Or values small? No, values are not small. N can be big, m can be big. So how is this product influencing the previous thing? Let's look at till n minus 1. If you have all the products till n minus 1, and then if you're looking at this thing, okay, so we have to think a bit like, can you simplify this? Or else can you write the product till n in terms of product till n minus 1 somehow? Let's try to write it like that once. Product till n equals to an plus an minus 1 times product till n minus 1, right? Now we want sum of this over all possible things. Let's say you have sum of this over all possible things, but then this will keep varying. Let's try to write it like this. What is Pn minus 1 again? So this, let's, can we write this as Sn minus 1? Let's try to write that as Sn. Will that simplify something? Can we write this as Sn minus 1? Then can we get something for Sn? An squared times Pn minus 1, right? Plus An times Sn minus 1, is it? So if you expand this thing, this is pure luck, I guess. This is the product. So an squared times the product, which is Pn minus 1, and then uh, an times an minus 1 times an minus 1 plus an minus 2 and so on. So that is nothing but n. This is nothing but s of n minus 1, right? So I think we are able to write Pn in terms of we're able to write Pn in terms of n times p of n minus 1. And Pn minus 1 doesn't involve an at all. Okay, and Sn we are able to write it like this, and this is purely independent again. Is this luck? So now you have to sum this Pn over all possible yes. Okay, you have to do sigma over a Pn. This is what you want, right? And what would that be? You will keep all possible values for an, right? And then let's say an, you are fixing something for an, okay? How many? Okay, you have this thing, Sn minus 1. Let's just fix a1, okay? How do we write this? A1 times Pn minus 1 plus Sn minus 1, right? If you're fixing an, a1, and how many things will be like that with a1, with value being a1? That is nothing but sum of this. Let's say we have p, we have s. Let sig p of n be summation sigma over a p of n, okay? Sig s of n be sigma over a s of n. You guys will click on videos that has math for CP, but you guys won't focus when I'm trying to do something math here, right? You guys take my content for granted. This is math a bit, right? This is a bit of math. I'm trying to fix one thing and then I'm trying to think of how the summation will go from here to there. Because sigma over a is what we are doing. I'm trying to divide that over a as being a1, being a2, and so on. Okay, this is how you can divide that summation first. Now I'm trying to look at this one. So you're trying to do this for all arrays where a1 is there, and then all possible values for a2, a3 will come here. You're only fixing a1 here. I mean, a1 and a2 is confusing now, but let it be v1, v2, v3, v4, v5. Yeah. And now all possible values will take place here. That is nothing but sig p of n minus 1, right? And all possible values, you're summing this over all possible a of length n minus 1. So that is nothing but sig s, right? And now we are adding this thing. So what will this become? This is sig p times m times m plus 1 by 2, which is nothing but v1 plus v2 up to so on, right? That is that times sig p of n minus 1 plus how many different values are there? M values are there. Sig s of n minus 1. So this is sig p of n minus 1. Sig p of n. Okay. We have to write such a thing for sig s2. Okay. What is s of n? We have a n squared. Damn, that's scary, isn't it? We will fix the value v1 again. Now v1 is fixed and this doesn't involve v1, this an value, and then this is nothing but sig of p, right, over all possible values. This is nothing but sig of s, right, over all possible values. And then if you sum this shit, what you will get is sig s of n equals to m into m plus 1 into 2m plus 1 by 6. That's what sum of squares, right? 1 square plus 2 square up to so on m square is n into n plus 1 into 2m plus 1 by 6. Is that sum of squares? Let me check with 1. M equals to 1. Yeah, I think that is sum of squares. Let me check with 2. It should be 5, right? If I keep 2, 2 and 3 will get cancelled. These 2 will get cancelled. 4. Yeah, I think this is the formula. And if I add m plus 1 whole square to that, m plus 1 can be taken common, and then it will become 2m square plus m. Okay, that's complex. I was trying to do m plus 1 and then see the formula adding up. I'm trying to prove it by induction, but yeah, light. Let's not do that. Now v1 plus v2 up to so on. So yeah, we have these two formulas. Let's call this as S1 or M capital M1. Let's call this as capital M2. Let's call this as capital M0. Okay. Int nm. Int m0 equals to m. Let's say m1 equals to m times m plus 1 by 2. Let's say. Okay. We want this shit. Can you get this shit without dividing by 3? What is mod inverse of 3? How do we get that now? I'm not doing CP. I even forgot this number. Oh, it's divisible. So, n3 equals to m plus 1 by 3. Because if you do into 3 for this, you're getting m plus 1. So we have m1. Now I'm seeing this as m1 times 2m plus 1 by 3. Should be fine. Where are we now? Let for n equals to 1, let's find the values. Or let's find the values for n equals to 2. What would be the values for n equals to 1? n equals to 2. N equals to 2, the values would be 1, I guess, right? Pn is 1. What's supposed to be the values for n equals to 1? What would p of 1 be? If p of 2 is a1 plus a2 times p of 1, p of 1 is supposed to be 1, right? That's it. And over all possible a1s, how much would that be? Sig p of 1 should be m, maybe. Right. Let's try to confirm this a bit. And sig s of 1 should be, what is s of 1? S of 1 supposed to be what? S of 1 supposed to be 0, I guess. S of n minus 1 supposed to be a of n minus 1, which is nothing but a1. If you sum this s, sorry, this is supposed to be a1. Because if you see Sn is supposed to be n times this is nothing. So that I think this is supposed to be a1. And then this will be m times m plus 1 by 2. So this is nothing but m1 and m0 and m1. So we have 1. We have to start from 2. Mu nu sig p equals to, what is nu sig p? M2 times, sorry, M1 times, wait a minute. Yeah. M2 times M0. M2 times sig p plus M1 this is. Have I overcomplicated this problem? I don't know because I went with the flow, right? Like I got something and then I was going ahead with that. Maybe I have overcomplicated this shit. But what can I do if I'm getting them a bit quicker? That's passing, guys. That's passing. We wrote some shit. See my math. How clear it is. Like, how clear. So, math comes from clarity. Math is not like doing some great things, okay? If you know what the fuck you are doing, you can do it, okay? See, it's correct. So, how are we now? Where are we now? I'm not in IIT Madras. He got married. Who the fuck are you guys talking about? Who the fuck is this one? Is that a guy or a girl? Wait, screen share is not visible. From how long? Someone could have called me, right? From how long? Is it visible now? If this is first, then who is this one? Yeah, bro, I saw you. You're calling me. Oops. I tried taking it like this, but then it spilled water on my hair. Have my tissues ready. I will wash it off. It spilled water on my keyboard. I don't know why I thought of doing that. But yeah, so guys, what I did was wait, how much have you guys seen here? I wrote a lot, but how much have you guys seen? When did screen go? When did screen go? Wait, when did screen go? Because I wrote a lot of math here. I wrote this and then I converted this summation of v1 to m into m plus 1 by 2, and then I converted sum of v1 square to m into m plus 1 into 2m plus 1 by 2, 2m plus 1 by 6, and then I have actually done what I have done was I have done 998244353 plus 1, which is 354 by 3. That was divisible by 3. So what I have done was I have done m plus 1 by 3 as inverse of 3, because if you see 3 times inverse of 3 is equals to m plus 1, which is 1 with respect to m. So 3, so this is the inverse of 3. And then what have I done? It was very nice after that. It was m1. So I have calculated m0, m1, m2. M0 is sum of ones. M1 is sum of m, 1 plus 2 up to so on m2 is sum of 1 square plus 2 square up to so on m square, which is nothing but m1 times 2m plus 1 by 3. And then the formula I have applied m1 sig p plus m0 sig s, m2 sig p plus m1 sig s, and then it was done. So it is writing recurrence relations. Like the topic name can be recurrence relations. This is a good problem for recurrence relations. Okay. Recurrence relation. What does recurrence relation mean? What are you guys talking about? What does JD means? It's not JD, it's just water. So how long has the screen gone? 5-10 minutes. Pradeep, how long has the screen gone? What should I practice? Drinking water? Fuck. Okay. The problem got accepted actually. On first try, I haven't even looked on any examples. I have just done some math. I just wrote some equations and then I coded it and submitted it. Simple code, small code. It got accepted. See, code will always be simple. See how I wrote a code, simple code. And this is just the explanation. I was very clear here. I first defined Pn, and then I defined Sn, and then I'm trying to define what is summation of over A. A first fixed value of An, because and then it's recursive, right? Now if you fix a value of An, you have to vary all other remaining things. That's nothing but sig P. You have to vary all other things. So that is nothing but sig S. And then you're adding it with respect to all different values. That will give you this. That will give you this here. Is this clear, guys? See, math is nothing but clarity. Like you have to try to do things clearly, step by step. Okay. then you will improve your math automatically. Because here I have tried being clear. I have tried being very clear in defining things. So if you are trying to define more before working on that, because I defined what is a and pn very clearly, and based on the definition I even extrapolated what would s1 be, what would p1 be. I wrote p1 equals to 1, I wrote s1 equals to a1. So it's about defining things. How willing are you to define something and then to work on that? That's what math is. Okay, if you're willing to do that, I need not have done that. I would have I would have started from p2, but I started from p1 where things are unclear, and then I have understood what should p1 be, what should s1 be, right? Right. It's not about practice, it's about willing to do. I gave many examples here, right? Here this is not math at all. It's like trying to write something from n to n minus 1. Can you separate things out? Because you have to expand this to separate things into n minus 1. You have to separate an from an minus 1, right? And then if you try to separate them, you can see if you want to separate an, you have to define something else like this. This is having only n minus 1. This is having only n minus 1. So that's it. It's not too complex here. This is having only n minus 1. This is having only n minus 1. And then can you also do the same thing for this product? We were able to do the same thing for that product too. The try was to separate an from other things, because in this they mixed an with an minus 1, right? The try was to separate an and an minus 1, so that you can write some recurrence. Recurrence in the sense you can write some equations for length n with respect to length n minus 1. I hope that's clear. I missed registration, bro. I should have. Okay, now we are at the next problem. Mark 0. So far 3 is done. You're given an array of n integers. Okay, one of my friend has called me. That's nice. Pradeep has texted me 6:28 itself. I should have seen it. You're given an array of n integers. You can perform two types of operations. Select an integer x and update. I'm eating Hasmola now. You can perform two types of operations. Select an integer x and update ai equals to modulus of ai minus x. This costs 0. You're able to change an element for cost 0. And the value is modulus of ai minus x. Select an integer x. This is from 2 to here. This is from 1 to here. Because if you select 1, it will become 0, I guess. And update ai equals to this. What do they mean by length at most 15? If n is too big, how can we do it within at most 15? No, for all of these things, it will become like that. And then we have to do it with in at most 15 operations. N less than or equals to 1000, ai less than or equals to 1000. We have to judge the problems. What do they mean by we can do it with respect with at most 15? First, you have to find minimum cost, which is nothing but minimum type 2 operations you can use. Okay. type 1 and then we have type 2. You can think, when can you only use, when the minimum cost is 0, can you only do type 2 operations and then make these things 0? To make these things 0, you have to use an x where ai equals to x. That means before using this x, you want all the ais to have same x. Otherwise, this will not work. So first you have to make them same. If you make them same, then you can use operations of type 1 to keep reducing, and then making that. So it's all about making them same. Okay. Or you can do this modulus of x. See, AI mod x is nothing but if you do the above operation so many times, can you attain mod x? Maybe not. As long as values are greater than x, then you can do that. But when some value become less than x, then it will flip inside, right? What if you do mod 2? It will only leave you with zeros and ones. And the problem is solvable whatever the values are. So if the values are 1 comma 2, then actually you cannot do much. If the values are just ones and twos or zeros and ones, what about then? What can you do then? If all values are different, you must do this thing at least once. Maybe sometimes you can make them equal using this, but not always. Sometimes you can make them all equal using this one. Because if things are above and below, if you use that, everything will come to there, come to equal distance, right? Zero and one. If you take now with 1, these ones will become 0, these zeros will become 1. If you do modulus of x minus 1, a minus 1. So let's say if you're only given ones and twos, okay? Whatever remainder greater than 2 you do, these things will not change. Now, how will you make this ones and twos same? And then how will you see? It's always about trying to think of the right problems, not the wrong problems. Thinking about 1 and 2 is right because it's a possible test case, right? And this will not get affected by operation 2 at all. So how would you separate these values? If one value is same, it can never separate with respect to this. But how can you increase the gap between them and then somehow make them same. Maybe if you take modulus of a minus x with something that is half of this, then what happens? This will flip, this will also flip. And then if you take remainder with this value, then this will come to 1. Then the gap will increase. Then you can take middle. So I think I have done this shit. See here, let's say you have 0, you have 1. Okay. So what I was telling was you have 2, you have 3, you have 4. This is one test case where you can have all the values to be zeros and ones. Now what I will do is I will try to flip them to above using by doing modulus of 4 minus value. You can flip them to here. Okay. Now what you can do is now you can take remainder with 3. If you take remainder with 3, what happens? No, not remainder with 3. Remainder with uh, they will always be adjacent. How can you increase the gap between them? I want to make them equal. I wanna take you somewhere so you know I care. When my hands between. Okay, I can increase them by taking remainder with 4. Then 4 will go 0 and 3 will stay here. Then I can increase the gap. But we want the gap between them to be even, not odd. Is that never possible? If I take with remainder with 4, then 4 goes to 0. 3 will remain there. But the gap between them is again odd. But let the gap be odd. After this, let's say we are taking remainder with 4. Then what have happened? 0, 1, 2, 3. 3 things remained at 3, 4 things came to 0. Okay. Now let's take remainder with modulus of x with 6. Then 3 remains at 3, 0 goes to 6. Now take remainder with 3. Everything comes to 0. So what all have we done here? We did two operations of remainder. With one operation, what happened? 0, 1. Okay, and then what did we do? We flipped them with respect to 4. Okay, 4 minus a. Where did it take us? Zeros come to 4, things came to 3, ones came to 3. And then what did we do? A remainder 4. And then what did I do? 6 minus a. Then this goes to. You need not do that again. You can just do remainder 3 here. Done. So remainder 2, 4 minus a, and then reminder to make it to 0, reminder to make it to 0, because the only problem was you cannot do reminder 1 to bring this down. So you're taking things above and then bringing them down. This is too simple. Reminder 4, reminder 3. Yeah, sorry. So in three operations you can do. In cost 3, it's always possible. In the worst case, the cost is 3. See, in the worst case, the cost is 3. Don't spoil the problem for me, okay? We don't have viewers. Aren't people excited about CP? I'm a grandmaster, guys. My rating is just I have people calling me grandmaster. As a joke, obviously. I'm candidate master. We have too many problems to solve. We have to think about this quick. When can you do with less than 3 operations? When can you do? I think it's about ones and twos. It's about if you have an odd number and an even number. Because uh, okay, when is cost 1 now? If everything is divisible by some value, then it's cost 1. Is that so? What happens when you do x minus that? Sometimes a will become x minus a. In this case, reminder can change as we like. So maybe there are cases that can be done with lesser cost. I will go to next problem, guys. I mean, it seems there is more guessing here. I cannot try to think of proofs of more things. I'll try to go to next problem. I'll come back here. This is very similar to product positive negative problem. The only difference is you delete subarrays with product 1 instead of minus 1. They're playing a game. It is guaranteed that a1 equals to 1. Either ai equals to 1 or ai equals to n minus 1. Okay. In single move, the current player does the following. He chooses something whose product is 1, delete the subarray, concatenate the arrays formed. So the same thing again. It's nothing but chooses a non-empty subarray with even number of minus ones. Okay, screen is there, right? You will choose with even number of minus ones. Whoever cannot do that will lose. Okay, if total number is even, allies can take everything. That's a test case here. But even if total number is odd, allies can win here, it seems. Okay. What are some losing positions? What are some winning positions? Let's try to write that. Let's put W's here. Let's put L's here. Only one, only one minus one. This is a loss because you cannot do anything here. Okay. Only one minus one is a loss. So anything that can lead to this is also a win now. Starting with minus one and then something with even minus ones, or something with even minus ones and ending with minus one. In this case, what you can do is you will remove this thing and then this will be left out and then the other guy is fucked. Losing positions or something, whatever you do, you go to winning position. Winning positions are something, there is a way you come to losing positions. That's how it is in general games, because here there is a way to go to losing position, which is removing everything. So what did this cover? Odd number of minus ones that start or end with minus one, right? Odd minus ones that start or end with minus one. So what is left? You have to think about odd minus ones that start and end with 1. Odd minus ones 1. Here, whatever the first guy does, can you say something? Odd number of minus ones. He has to remove some even number of minus ones, right? So whoever, so if you see here, if the n becomes minus 1, that's a losing one, because if the n becomes minus 1, the other guy will win. You cannot make the n minus 1, because if you make the n minus 1, even if it is even, it's winning. Even if it is odd, it's winning. So it's about fighting for that end a bit, like fighting for that. I don't want to make the n minus 1 kind of thing. Let's say you have 1 1 1 1 and then minus 1 1 1 1 1 1. People will fight to not make this n minus 1. If someone removes till here, the other guy will remove till here, and then the next guy will must remove this. Then the end became minus one, and then you're fucked. So it's like people trying to find to not fight to not make the n minus one. And also, if the value is odd, people remove uh, even number of minus ones. So the value will always be odd. If the value is even, it's done already. If the value is odd, people value will always remain odd. And if the value is always remaining odd, it's about okay. If the value is odd, it's about not making the n minus. It's about not making the n minus one kind of thing. Okay, so you can remove some things that are having minus one, and then you have to make the state equals to. So if you see whatever you do, what you will remove is some minus one to some minus one. Like you will remove some even number of minus ones. Okay. So the first guy has more power, right? The first guy has a bit more power because he's getting the first move. Let's think about these cases, which is winning and which is losing. Okay. In these cases, should I smoke a cigar? I'm just joking. I don't smoke, guys. I don't smoke or drink. I just have it. Someone else's, not mine. I don't know who all watches my videos. I'm not should not be distracted. Let's focus on just these things. Is there a winning position? Is there a losing position here? So if 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 these two lengths are unequal, if these two ones are unequal, player one can make them equal and give back to player two. Now player 2 will suffer because he cannot make them empty. This is a classic game, right? When you have two stacks, whoever makes it unequal will lose. Uh, whoever gets the equal thing, he whatever he do, it becomes unequal. Then the other guy can remove the opposite side to make it equal. And finally, someone has to remove that. So if it is like this, it's about equal or unequal. If it is equal, whatever the first guy does, it becomes unequal. Then the next guy will make it equal. So if it is only this, it's about equal and unequal, okay? But what about when there are multiple minus ones? Baby, when build this house on memories, take my picture. Say till you say one more fantasy. Promise me the house of memories. So if you can make something as equal once minus 1 equal once, then that's winning. If you have minus 1 in the beginning, it's winning. If you have even number of ones, it's winning. Else, if you can make it into this equal ones on both sides, then it's winning. What all configurations can you make like that? Let's say you have 1 1 minus 1 and so many things, but then you have 1 1 here, and then whatever the shit is there, then you can remove this side entirely, and then it's winning. So if number of ones here is less than or equals to number of ones here, it's winning. If number of ones here less than or equals to number of ones here, it's winning. Baby, we build this house. If number of ones in the beginning and number of ones at the end are unequal, it's still winning. Why? You can make it equal. But if number of ones in the beginning and number of ones in the end are equal, then what? So these ones here and these ones here are equal. Then what? Whatever you remove here, but then maybe you can make them again equal, because if number of minus ones are many, maybe you can make them again equal by removing something like this. Bro, you should not help me, okay? Then it won't be life solving. I will try to get there. Don't worry, I will get there. I will solve it. I'm sorry. Maybe you can try to think of some other problem. I will go there soon. Okay, Sujal. I will see it. I will see it after I solve it. Okay. So let me think a bit. I mean, it won't be as complex as what I am thinking. We have to think more to get to a to get to a simpler solution always. So now we have to worry about what if these two things are equal, right? Wait. Even if those two things are equal, you can remove all of these things, and then it will become equal. So it's done already. It's done, guys. It's done. It's simple and it's done. So if both of the ends are okay. So if both ends are unequal, you can make them equal, minus 1 equal. Okay, if both ends are equal, if there's only one minus 1, you are fucked and P2 wins. Else you can remove the remaining things. You have equal, okay, minus 1 equal, some shit in between. You remove the shit in between. Okay. And then the other guy fucked. That's it. The problem is done. It's simple. Okay. Sujal, I have solved it. Okay. I was unnecessarily overcomplicating. I can see that. And then I have solved it. It's that simple. So now we have to check. So what all? So we have to make implementation more clear now. What all do we find? If even minus ones, done. If begin or end with -1, done. You keep only -1. You remove everything else. Now it's not beginning or ending with -1s, right? It's not beginning or ending with -1s. So now what would you do? You have ones, you'll find the first -1, you have last -1, you have ones, okay? If there is only if these two are unequal, you can start from here or here. Whatever is the bigger side, you will remove all of them and then you will make them equal, done. If those are equal, done, based on number of -1s. So you want starting ones, you want last ones. If there are even -1, it's done. Now it's done. Oh, n can be 1. Shit. What if n equals to 1? If n equals to 1 and if there are odd number of -1s, Bob wins. Now what about the problem? You have starting number of ones, you have ending number of ones. Let's count both these things, okay? There is at least one -1 in between because number of -1s is odd. Odd means they exist, right? So now you are at this place and you are at that place, right? What do you do if I equals to j? And if okay, you want number of -1s too. So let's just keep number of -1s instead of XORing. Let's just count number of -1s. Okay. Now, if I not equals to j, you have a way, and the way is, what is the way? If I not equals to j, let's make it like if I less than j, I greater than j. Or let's make it if I equals to j separate, and then else if I great. I don't know what looks cleaner. If I less than j, means this side is smaller, right? That side is bigger. So what do we do? I plus 2, I guess, because I have made it 0 based index, right? Because I have made it 0 based index, what I should do is I is the place where that is there. I is number of zeros. I is number of ones. I plus 1 is this. Let's do it. I plus 2. From I plus 2, you have to remove everything till n minus. I is number of ones. N minus I. Because you're removing that many ones, so that would be the answer. Here, j is number of ones. So you have to remove that many j's. So it will be j plus 1. Okay? You will remove everything. So you have j ones here. So this is n minus j. N minus j minus 1. Okay. And this will be greater than or equals to this because 2j is less than or equals to n minus 1, it seems. So will this be greater than or equals to that? Because this is less than or equals to the, this is after that minus 1. And that is, I greater than j. So this will satisfy likely. Leave that. If it goes wrong, I will think about that. So here's what we do is we remove the sheet in between. I zeros, I ones are there, and then you are removing the sheet in between. I ones are at the end, and then you have to remove the sheet in between. So what do? N minus I minus 1. So only thing I'm worried about it is this, but it should be right, because if this is right, also this should be right, right? It's symmetric, right? So we are removing 3 and 4. If you remove 3 and 4, yeah, it's good. Removing 1 and 3. Let's just submit it. Here we are removing 1 and 3. Baby, we build this house on memories. Take my picture, shake it till you say. J is not number of ones. J is the index. So number of ones is n minus 1 minus j. I cannot call myself a grandmaster and make such silly mistakes. I declared a variable, I moved it, and then I was not knowing what the fuck it is. And then I was thinking it number of zeros. Why did I do that? So yeah, it got accepted. Nice, Sujal. Congratulations. Huh? Yeah, I will be international grandmaster. I'm not quitting this shit until then. I will have my kids, they're becoming grandmasters, and I will be calling myself, I'll be international grandmaster, which I will never be though. At 47 or 67 or more. We have MST problem, we have jumping one or two. Am I scared of low submissions? I'm not at all. Problems are problems, okay? Yeah, they may appear scary, but still, they are all nice problems. All problems are nice problems, okay? Jumping one or two virtual sets, MST. Oops, what the fuck have I done? We'll go for jumping one or two first. So this is jumping one or two. For a given array of size and define f of a in the following way, sequence b1, b2 up to so on, b of length b is said to be valid if the following conditions hold. b1 equals to 1, b mod n equals b, the last element bn, and every in between difference is either 1 or 2. So jumping 1 or 2. The score of the sequence b is summation of all the values of a of b of I. You have an array a, the values are between 1 and n. The score is whatever the array a has the values, right? F of a, the score is that, and f of a is the minimum possible score of a valid sequence. So score of some sequence b is uh, so it's a nice problem. It's not like you need some prerequisite to do this problem. We have to maybe analyze the sequence a bit, maybe, and then you will get the okay, these are the sequence, and then maybe you will get. You have to prove to, if you believe in golden rules, there is a simple proof that says, okay, this is f of a for this or something like that. Given integers n and m, find the sum of f of a over all sequences a, such that modulus of a equals to n, values equals to this. Oh, these values are small. That can be a bit complicated because now you don't know what to simplify. Maybe something will simplify, maybe, but still it will get converted into something solvable. You have to believe that because values are small. Maybe you can brute force and then you will find some structure. You have to think about this problem a bit. First, you have to simplify what is f of a, and then you have to think how can you count that shit quickly for everything. When m can be between this and n can be between this, how can you count that? This seems very unrelated, right? Because valid sequence depends on two jumps, and then you're having scores. That's what I meant. Have some shit to eat. Chocos and some brownie. I will go to MST quickly. Let me try this problem a bit more and then I will go to MST, okay? Let me try this problem a bit more. Okay. It's about minimum possible score. If it was maximum, we could have gotten sum of total itself. See, I think without simplifying f of a somehow, you cannot solve the problem that easily. But those missing numbers are not adjacent. So that's a nice thing. Non adjacent, that's definitely a first step. Aristotle. Have you time traveled? That's definitely a first simplification. This is the problem is nothing but, yeah. So we have 2 points by our Aristotle. That's definitely a first step. That's definitely a first simplification because that's an easy way to look at. That's a simpler way to look at it, right? Rather than jumping one or two. I have seen it like some 1111 gap, 1111 gap, and so on. But yeah, this must be taken. The starting value must be taken. The last value must be taken. You can miss few things in between, but then you cannot miss consecutive things. And now, if you think about it, this is a maximization problem, I guess. And you may have two ones in between, but you will never have three ones because then you can make this zero, right? So you may have two ones or one. Okay? Like this. Can you find f of a given a? You can do this because you can try to know what is the non-consecutive zeros maximum sum. What? How would you do that? You will think like till here you will find the dp, and then you will be like, okay, if I take this zero, I should not take this, and then what is the maximum that can be taken till here? You will do it like that, right? What is the maximum that can be taken till here? I don't know. My head is aching somehow. You can read the problem. Yeah, leaving the first and last element. So this is not too complex so far. Like it's not too complex. The thing is, how would you? The thing is, it's like two contradicting problem. I mean, we never encounter such a problem in this size, but it's still solvable because they asked us to solve. So let's try to see how would you do this. See, the thing is, because it seems like it's difficult, it's likely in this values, like it's n into m, definitely n into m. We will try to maybe uh, characterize this different possibilities into n into m somehow. I think it's like n into m, like we incorporate values somehow. Value of the sequence sum so far. So value of sequence is less than or equals to n into m, right? So it's likely n times this value algorithm, because n cube is possible now. I don't even think this is a nice problem. I don't even think this has something difficult or good. It's just brute forcing it, I think. Because for one thing, the DP proceeds like choosing AI plus till I minus 2 max cost. not choosing AI plus till I minus 2 max, I minus 1 max cost. Maybe you can brute force this value. Maybe you can brute force this value. Maybe you can split the different configurations of A. Maybe you can split the different configurations based on the value that is possible for I minus 2 max cost. So a sequence of A has I minus 1 max cost, comma I minus 2 max cost. For it to proceed and build up, if you are only counting max cost per sequence, these are the only values that are being necessary for us to proceed further from I to I plus 1. Right. Sorry for this. Let's go to MST. We're not getting much here. It's like we cannot fix only one value. We have to fix two values to proceed further, right? Because when a new thing comes, when a new value comes, how do you compare? Let this be uh, Jedi Jedi minus 1, Jedi minus 2. How do you compare? Jedi equals to AI plus Jedi minus 1, Jedi minus 2, max of Jedi minus 1, right? But it depends on both the values because a sequence uh, that has this, you cannot just fix by this value. It depends on both the values. But if you fix one value, the other value cannot be far apart because if it is far apart, it's useless. Because if it is far apart, it is useless. Because if the other value is much less than this value, if the other value is less than capital N, because the less than capital M, because the values are between 1 and M, maybe that is the thing that helps us. The states need not be weird and weird. The states can be this, and the other thing can be like from here till minus N at max, because if it is even lower, then it's useless. If it is even lower, then it's useless, right? This thing, if it is even lower, then it's useless because we will use this itself. So maybe those are the states we maintain, not value times value. Value, I want a better term. Let's call it max sum. Not maximum times maximum, but maximum times n, because this can be Useful states are max time, maximum times maximum minus 1, maximum minus 2 up to so on, maximum minus of n minus 1, right? All other states we will just call them as I minus 1 max cost comma I minus 2 max cost less than I minus 1 max cost minus n minus 400. If you maintain states in this way, now how many states do we have? Now we have n times m times n. These many states. Okay, for a sequence you have these states. For a sequence you have these states. Now let's try to invert and call them as for these states how many sequence you have. For these states how many sequence you have. You cannot do n power 4. Can you simplify it further? I thought I saw your face today, and I just turned my head away. Your face against the trees. I'm not so good too. So guys, let's go for MST. You are given an integer and say this is something like that. If you can reduce states somehow a bit further, if you analyze, if you find some one extra point, maybe then we can count it. I think there is no other way. There is no other simplification of f of a because f of a cannot look that good because if you analyze one array, there is no other algorithm than brute forcing it via DP. Because if there is no other algorithm than brute forcing it via DP, you have to brute force it via DP and count somehow everything. And if you have to brute force, you have to split these things based on the same algorithm. You have to use the same algorithm because f of a, I don't think there is anything else. And if you are using the same algorithm, you have to make it somehow be a bit better. Like you have to somehow do the things parallelly, counting things parallelly. You have to do that. I thought I saw your face today, but I just turned my head away. Your face against the trees. The fuck was that? I don't use Vim. So we have great people over here. We have Aristotle, we have another great polymath. That's what, right? My viewers, I expect a lot from them. So let's read this stupid problem. See, this problem itself doesn't have like great logic. Like we can see that it's not great logic. We can see that it is about some brute force stupid DP counting. There is no like great simplification and then it's done. You're given an integer n, we call a matrix W of size n cross n good if it satisfies each of the following conditions. It should be like symmetric. This should be 0. The set Wi comma j forms a permutation of okay, and then it's a permutation of this thing. Okay, we have weights from 1 to up to so on n into n minus 1 by 2. A good matrix define f of w in the following. Consider a complete weighted undirected graph n of with vertices with the weight between ith vertex and jth vertex being this weight. F of w denote weight of the minimum spanning tree of this graph. You are given two integers n and k. Does there exist a good matrix such that f of w equals to k? So this is a bit of constructive problem. You have to think when it is possible and when it is not possible, right? Weights can go from n into n minus 1 by 2 to yeah, weights are of order n cube, right? You have to find when it is always possible to construct a graph, when it is not possible. you can likely construct most of the times using some kind of structure. You have to give importance that the values are from 1 to up to so on. 1 to up to so on. The values are from 1 to up to so on, increasing type shit. And then minimum spanning tree. Minimum spanning tree. What's the minimum value? What's the maximum value you can attain? You can think about those things. And then you can think if everything in between can be attained. What is the maximum minimum spanning tree value that can be attained? This is a complete graph. And you can never use where are we, guys? Again, what is the maximum value that's possible? What's the minimum value that's possible? We know something about minimum spanning trees, right? What do we know about minimum spanning trees? I'll reset this shit. Oh, if you have a cut of vertices and you have edges, let's say this is the minimum value among all those edges. This must be present in MST. Wait, why is it so thick all of a sudden? So, guys, I don't think I can solve difficult questions. Nobody called me. Team was fine, but now I'm not able to do any problem. Should I try to think about this itself? Let me try to think about this itself well. We know this about that. That must be present. Guys, I don't think I should be doing CP. Yeah. We should try for minimum thing and then we should try for maximum thing. So what is the minimum possible cost? Uh, let's just connect 1, 2, 3. This is the minimum possible cost, right? Because the values are like that. 5 and so on. So this is the minimum possible MST, right? Now, can you get one more cost? Minimum cost will include 1, 2, 3 up to so on n minus 1. These weights it will include. Can you do plus 2? You can likely do that. Maybe you have to just replace some value with some higher value, right? So now how can you do that? Like can you make it, because one will always be taken. You cannot do anything about that. Can you skip two sometime? Is there a way where you will skip two? Let's say one will always be taken, and then you keep 1 comma 2 one side, and then you keep remaining things at the other side. Then 2 also will be a cut. 2 also must be taken, right? 1 and 2 must be taken always, because if you keep the edge one side, and if you keep the remaining all the other things the other side, 2 will be the min cut. So 2 must be taken, but 3 can be skipped. You can skip 3 by placing like here, and then 1 will be taken, 2 will be taken, 3 can be skipped. So if you do that, if you do 1, 2, 3, 3 will be skipped, and then let's start from 4 and then do the remaining things. Okay, from 4 let's try to do 4, 5 up to so on n minus 2. So now what have happened when compared to before? You're missing 3, you're adding n minus, oh that's a lot. So instead of missing 3, let's miss n minus 1 and then add n minus 2. This should be possible, right? So you have n minus 3, n minus 2, n minus 1. We are trying to miss this one and then add something else. How can you miss this one? You can just place that value here. N minus 1 you will place here, and then you will place n minus 3 here. Because now 1 and 2 has already been added, you won't be adding n minus 1, because 1 and 2 will definitely be added in the beginning. So you cannot add n minus 1, and then because you cannot add this one, you are getting this one. n sorry n. So you can get n. So what does that mean? You can get 1 2 up to so on n minus 1. In the same way, you can get 1 2 up to so on n. I think you can keep doing this again and again. You can keep doing this until you have how many things here? You have n minus 2 things here. And all of them will be added before you come to n minus 1, because all of them are smaller, right? All of them will be added. In this graph itself, all of them will be added, because in this graph, if you apply Kruskal's algorithm or whatever prim, or I don't know the name exactly, but yeah, you will add all of these things. Then you have n minus 2 C2 number of ways to choose a pair among them. So till n minus 2 C2, you can go. You can do that. So there should be a simple way, because you have to code, right? You cannot have multiple patterns, two, three, four, five patterns. Till n minus 2 C2, you can add them, and then you can you can add everything smaller, and then you can go to the next value. You can put the next value here, biggest next value. And after this, how will you increase things? I mean, if you run some algorithm that starts with minimum edge itself, one will always be taken, right? Two also will always be taken. I think now you can maybe skip three or something like that, and then do the same thing, because if you can skip three, now everything will be increased by plus n. You can skip three now, and then you can apply almost same similar thing. But then, can you cover everything? And what is the maximum you can go? One, two, three. I think streams will take a lot of energy. Like, you cannot start and then you cannot like slack, right? You have to do justice a bit. And then if you have four, you can add five here. You can add six to here. And if you are going like this is even better, I guess, because now you can add. Now here itself you can add too many things. You can add three. You can add three till here. You can add five here. You can add six here, because four, five, six plus one, seven, right? You can add eight. You can add till there. So you can skip all these small weights. In this way, you can skip many of the small weights. So how do we solve this shit? I'm tired, guys. I cannot be doing this shit. I have other things to do. I will end the stream, but then it's not good to end the stream like this. I see. Yeah, seems so. You can do one. Thanks for helping me a bit, but maybe you gave away a solution. I guess one. I mean, because this is nothing but 1248, right? Okay, if you go 1248 up to so on, okay. But I don't think this solves the problem entirely. This makes you go. This makes you go. I don't think this solves any problem because there are much bigger values, because sometimes you can take everything and then it will be very big. Is this giving some small value, or I don't know if it is giving big value? Okay, in this way you can try to put everything smaller first. Let's say 16, you have n cube, right? In this way you can go till whatever the k is, 10110, like that. You can go till here as long as this is smaller. What would you do with the remaining things now? Where would you keep them? Like, you have to add all the vertices, right? How would you manage those vertices? I don't think you will have enough two powers if you keep going like this, because you cannot have enough two powers. You will end at a time. I mean, this should not be very difficult. This problem should not be very difficult. You have to use induction better. To use induction better, let's just keep 1 to n minus 1 one side, and then n some other side. And then let's say you have all possible MSTs here. Now you have this value n that is also coming up with n minus 1 bigger weights, because those are the new weights, right? Let's say you have all possible MSTs, and then you have this n minus 1 bigger weights. Can you get for all these weights, can you get these weights plus this? Or I'm not able to do, guys. Should I go for some easy problem at least? I mean, this is not too difficult. It has 25 solves, no? Make zero should be doable. Right, guys, I'll do it later. But then I have even given this thing to some other guy. I think ending it better rather than delaying it like this, right? That should be fine, right? I mean, I'm not obligated to anyone here, right? It's like I'm not even having viewers and I'm doing this shit. So should be fine. I'm ending it. Bye. I'll eat something and then maybe I will do some work and then maybe I'll do something else. Bye.